Well, good morning, good afternoon, good evening, good night to everyone, wherever you may be across our lovely world. Thanks so much for joining us live here today. Hope you've worked out the slight time zone change. This is all based on American time zones because, American company, I suppose. So, it's actually for the rest of the world, it's all an hour earlier. So hopefully you've caught us if you've joined us an hour earlier. If you're joining us an hour later, well, the recording will be on Twitch and on YouTube. You absolutely won't miss out. So we are switching live on the AWS Twitch channel and also the YouTube. Oh, can't speak today. I need another hour to wake up, I think. And on the YouTube AWS events channel. My name's Julian. I'm a developer advocate, and I do a bunch of serverless stuff here at AWS. And we have two returning guests this week who are gurus in their field. Ben, welcome back to Serverless Office Hours. How on earth are you talking about serverless, and what brings you to do what you're doing today?
Well, nobody has stopped me so far, so I'm really happy to be back here on the show. So thank you, Julian. Hi, everyone. My name is Ben. I'm a senior solutions architect. I'm based out of Frankfurt, Germany, and really happy to be here and talk about serverless today.
Well, excellent. And welcome back. And well, I suppose, Ben does a bunch of serverless stuff. So I think we're basically going to MCP him up at one day, or we're going to have the Ben agent who's just going to be the guru on serverless. And also doing a lot of agentic stuff and some cool AI stuff. Marco, welcome back to Serverless Office Hours. For people who don't know Marco, how did you land up doing serverless at AWS?
First, thanks for having me here the second time. Starting serverless, I think it was the first time I said I don't have the mood to struggle with all the server stuff and seeking ways for obviously getting rid of all these undifferentiated heavy lifting, like managing instances, managing servers, and just wanted to, I would say, deliver business code, right? Business value, just what counts for customers, and it can be quickly as fast as possible delivered for and to customers.
Cool, excellent, love it. So we have people who are joining us online. We are live, so send us your questions, send us your comments. We'd love to hear from you. Peter Smith, very clever person, obviously, because he has a PhD. He says, I'll set my calendar reminder to US time, so change automatically. I feel for Peter because I know Peter personally, and he actually lives in New Zealand. So an hour earlier in New Zealand is not particularly helpful, actually, for the next few weeks. Well, some of us in Europe, because Marco, Ben, and I in Europe, it's actually an hour earlier in our days. That's a normal day, not the middle of the night. So, and welcome to Erie Edits, who says, to Ben, no one's stopping me is the funniest thing. Absolutely. And Reginaldo 8597, thank you for joining us from Brazil. So we have people from all over the world. So we love to know where our lovely serverless community is. So yes, put a comment in the chat where you're from. It's okay. So today's session is Serverless Resilience, a Practitioner's Guide. I don't even think we need to bother talking about this for an hour. Surely, we're in the cloud, we're serverless. There's no reason to talk about anything resilience. Surely, Ben?
Well, you might be surprised, let's say, because I think there's a few perspectives on resilience, right? When we talk about it, and well, for sure, there's the infrastructure part, and I think that's where serverless excels because it's something that's abstracted away for you. But hopefully, and as Marco alluded to, there's also kind of the business logic, the application part, and there I think we still need resilience. But let's take a look at something that might look familiar to you. So if we look at the dashboard that I have here, like who of you kind of recognizes that? And I guess it's familiar to most people. And for those who haven't maybe seen it, you're lucky, I guess, because this is the AWS Health dashboard. And I think when we talk about resilience, when we talk about this dashboard particularly, and you look at comments on social networks and somewhere when there is an issue going on, it's usually the statement of this does not reflect the reality that particular person perceives. And kind of the question why that is something we also want to try to answer today. I'm not going to spoil it. That would be too easy. But talking about and reasoning about resilience can actually be pretty hard or can be pretty complicated. So I'll leave that for a later moment. Right now, and I guessed it, you can probably guess what the next quote is, or the quote I'm going to show, because I think no talk about resilience is complete without having at least this one, at least one time. And I think it's been used very often. But I just want to reiterate or emphasize like one key point, right? So, well, everything fails all the time. That's fine. But we kind of need to be aware of it and need to prepare accordingly. And there's this spectrum of what can go wrong, right? So, and there is the little things, let's say a server crashes, or like even the not so little things, let's say even a complete rack is unavailable, or let's say hypothetically, or unfortunately, there's an availability zone issue and so on. And these are the things when we talk specifically about serverless, where you're lucky, right? Because these higher level services, these managed services manage all these components or these aspects for you. So shifting traffic from one availability zone to another, replacing failed instances and so on. But there's also other aspects of it, right? Where we say, okay, now your application has a bug. There's little we can do from our side to help you fix it. But the question now is, okay, what do you do, right? Do you accept that the user experience for all your users is degraded? Or are there ways to kind of contain that failure, to make sure that at least a portion or only a portion of your users is affected and maybe the others aren't? Right. So the key takeaway here is there is failures large and small, more often, less often, but you just can't ignore it, right? And even with serverless, it's just the kind of thing that can happen, kind of shifts from lower level infrastructure to like these higher level components.
Yeah, I was just thinking as you were talking about that, all really good points. And I suppose we always talk about security for this shared responsibility model. But actually, resilience is part of that story as well. There's a lot of stuff that AWS does behind the scenes, but stuff you need to do as well. And I suppose today's talk is also about, people talk a lot about shifting left in security and shifting everything left. So maybe resilience is a little bit of stuff you can shift left as well, if that's not a poor analogy to mess it up.
Yeah, and it's actually, I think it's a great analogy because also, and we're probably not going to dive too deep into this, but resilience is also like security, not a thing you want to do once and you're done. Basically, security is something you need to update, you continuously learn and monitor all the time. And similarly with resilience, right? It's not a saying, I have a workload, I do an architecture diagram, and I tick the checkbox, I'm resilient now. What does it even mean, right? And your architecture evolves, your application evolves, your requirements evolve, and so does your resilience posture. So it's kind of this kind of mindset, similarly to security. Now, well, let's say we come from let's look at the different perspectives here on how you could think about designing resilient architectures. And let's start with something very simple where we say, how would we do this on premise? Right? On premise, we would probably have a data center and we would have our application running somewhere, and then we probably design like a failover, running it somewhere in that same data center, in that same data room probably, and have something to fail over. And when we move this to the cloud, it's a very similar architecture in the sense that we don't fail over in the same, let's call it data center, let's call it availability zone. These are kind of different but similar concepts. But what we can do is we can fail over to a different availability zone. And depending on your workload, you might also just be able to run in multiple availability zones at the same time. Like imagine having a load balancer that then distributes requests to the compute things in the different availability zones, right? And you see I'm kind of avoiding the term instance here. So now what happens with serverless, all of a sudden, you don't see, or you're not responsible for managing capacity in specific availability zones. It's abstracted for you, it's managed for you, which is one of the great benefits, that you don't have to worry about specific capacity planning, shifting across availability zones. So how kind of does now look this failover component for serverless? And again, one dimension you could say is, okay, now I'm not going to use different availability zones. We could use different regions. So let's say we have a second region where we can fail over, or potentially even, and I want to be absolutely crystal clear here, this is not how you should get started, right? So let me just get off the way. Don't start with your to-do app in like a multi-region setup. But, and you'll see this throughout today, if you have requirements that demand this, this is a way to achieve a higher degree of resilience. And then again, you have this option of failing over or running it in a kind of an active scenario. The thing is, there's still probably something that can go wrong, right? And that's also very important of being aware, what are the failure scenarios that we're talking about? Like, what do we want to protect against? And there is the ones which we can easily cover, right? So saying, okay, we want to avoid being impacted by an availability zone failure. So we have these kind of multi-AZ deployments, which is even something that with serverless you don't really need to worry about. But there are still other aspects, especially on the application side. Who hasn't really been impacted by like a bad deployment on like a Friday afternoon, right? It's something that can happen, right? And there's nothing like it's like very hard to prevent entirely. There can also be unintentional like changes, like misconfigurations, accidentally deleting the prod database. This has all happened, not to me, I promise, absolutely not. Or even like poison pill messages, where there is like some bug, like a latent bug you haven't discovered, and then a specifically formatted message, for example, like crashes your processing pipeline, for example. Right, so these are kind of failure scenarios that are not infrastructure specific, they're kind of application specific. And if we accept that, if we're now aware of this, the question now becomes, okay, how do we then ensure that the impact is minimized? Because that's all we can do. We cannot fully prevent failures. We can just minimize the impact. And one solution to this, one concept we want to talk about, and I think that fits very well here, is what's called cell-based architectures. Now, I'm just going to ask like the chat, who is familiar with cell-based architectures? Has anybody heard the term or even implemented it? That would be amazing, because then I want to hear your story.
Yeah, and even let us know. Yeah, you know, and also in general, the kind of resilience things that have gone wrong for you. We'd love to get some real world use cases, because I know some people are starting out with their students listening and they think, oh, what kind of stuff can actually go wrong? So yes, definitely, first of all, cell-based architectures. Anyone use that, even concepts or ideas from that? And then, yeah, tell us the things that have gone wrong in resilience. Worst stories ever, please. And no wrong answers. Yeah.
Yeah. And the idea behind cell-based architecture, and we're going to explain this in a bit more detail, is just, okay, we want to group, or we want to separate, we want to split, we want to segregate our application into these kind of different isolated cells, like logical containers. So what we have here is, and I purposefully left out any architecture like AWS service icons. It's just, imagine this is like an example application, right? So which is sufficiently complex. It's not just a Lambda function, but it's probably a bit more. And what we do now when you move to cells is basically you take that application, you take that architecture or the infrastructure supporting it, and then you kind of copy it or clone it to have multiple instances and like multiple instances of that architecture. And suddenly you have these cells. And the benefit will become just hopefully clear in a second when we dive a bit deeper into this. And there's again one aspect when we talk about, okay, now I have multiple, how does this even help? And just keep in mind that you could also do this like across regions. Yeah. So with that, I also see now the comment in the chat. Okay, let's dive a bit deeper onto what this actually is and how do you get there? Because again, you probably don't start with the cell-based architecture immediately. The question now becomes, how do we get there? And I think that's also where, Marco, you can help us out.
Well, even, I mean, maybe Marco, you are going to cover this, but what is the thought process where you are big enough to even think of having a cell-based architecture?
I think this is a pretty good question, because when we start switching back to my architecture diagram, we can start evolving on a simple architecture into a cell-based architecture. And along this design process, or that can be a discussion between us three, is what could be, I would say, hints, indications for now your workload is probably either important enough. This could be one decision criteria, right? If it should not fail or should only fail partially, or if you're just reaching a scale where it makes sense to divide your users into logical boundaries, smaller buckets, to just have, I don't know, just 5% seeing a failure and not everyone. This is the initial introduction Ben had with service health dashboard, right? There's sometimes a question like I'm seeing or facing a challenge with my, I don't know, a specific service, but the service health dashboard is just indicating green. So there might be a mismatch in understanding what it means when is something green or not green, and what does it really mean? Does it mean everything fails, just a bucket failed, or a small portion of a workload failed? So let's see how we get from a simple architecture, which is our starting point here. So the button here is just as some sort of laser pointer to get the attention to the important parts when we add more and more things here. Let's start with a simple architecture, because as Ben already mentioned it, which is what is a good recommendation. You typically don't start with the most complex architecture patterns and just throw it at an existing application and cross fingers and hope things are going well or not. There's a thought process. You start usually or typically start simple, right? And so we will do as well. We have a simple basic serverless architecture, 3 services, an API gateway, a Lambda, and a DynamoDB. And with the API gateway as an entry point, we have this kind of doorkeeper, gatekeeper into our architecture. We get basic resilience patterns. We get a regional service. It's a serverless service. We don't have to manage infrastructure. We have Lambda as here as an example for the compute, which is also built highly available across all the SCs in our region. We got concurrency, parallel execution, all the kind of stability AWS provides with the services, and the DynamoDB as a NoSQL data storage layer. And with all these services, we get some initial resilience features pretty basically out of the box. We have multi-AC deployments in all 3 services. We get service level SLAs depending on the service. And we get automatic scaling scaling capabilities within certain limits. So, right, for Lambda, for example, we have by default in most regions 1,000 concurrent executions, which can be raised by creating a service quota increase requests. So you have your API gateway, which has certain limits. Then you can operate your service, and DynamoDB with read and write requests you can have, for example. So it's all scaling automatically. But what happens if you reach certain limits, right? And this is where you start increasing limits, but this might not be enough. And there's always something we call shared responsibility model. Should be just put here. And the first thing is what you usually try to decide is to which extent or to exactly which part of my architecture is a user responsible. Right. So ideally, you have a shared responsibility model. This a dotted line here will say, okay, besides sending a request, the user is not responsible of anything except should be valid data, yeah? not bad or malicious attempts. And all the rest is just handled by our serverless architecture. One of the first things we usually do is adding a couple of more services, as an example for an SQS queue, for example, to get some sort of resiliency in terms of something on our side is breaking, right? So the first thing, what can go wrong might be a wrong deployment, wrong code, we have an issue or a bug in our implementation, for example, which causes some errors and user requests are not properly handled. And this is something we should be aware of when building architectures. As I've said, where is the line of sharing or the distinguishing who's responsible for exactly which part? And in an ideal world, the user is just resending data or requesting data, and our architecture is simply stable enough to handle that kind of requirements from our users. So he's not really in charge of anything besides interacting with our applications. So this is a pretty simple example how we can modify architectures to be inherently more resilient by being more failure tolerant, for example, keeping all the messages getting in the SQS queue and being processed whenever the Lambda is working again, for example. So the user has not to do anything. But even with this kind of architectures, we see challenges. For example, your application is becoming successful, right? So your traffic patterns grow exponentially. For example, you have a Black Friday, you will have viral content, and now millions of people are just trying to access your applications and try to do something with your product, for example. And this might still crash your application. And even with serverless, there will be some challenges in scaling rapidly and with this amount of traffic spikes. Or you reach simply regional service limits where you say it doesn't make sense to grow this architecture without doing anything, and then becoming too big to risk a full outage, because with our simple architectures, we usually have either it's working or it's not working, because we simply can't route between different parts, what we will talk about. There's some other sorts of challenges that came up either with more success, so you become more famous and more people have an interest to see what can go wrong with the application. When we talk about malicious attempts, people try to cheat or trick your system, like sending wrong data and see what happens, for example, or you get just bad data or somebody tries to attack you. And so we have the potential question, isn't serverless already resilient enough with multi-SC? And we can see there are a couple of scenarios where we can clearly say, no, probably not, because there are a couple of scenarios where the simple architecture we see here and the technical capabilities don't protect against a set of failures. And this is where we talk about some sort of more logical failures, and we try to split our application into smaller portions to have different users sitting in different parts of our application. And this is where an idea is usually to talk about cell-based architectures. And let's magically switch with a click in our architecture, and a lot has changed, and we will now go through all the new things that came up here. So we have our initial architecture, we have a user, and our simple architecture with these 4 icons. And let's talk about the couple of new boxes we have. The first one here is a cell. So what we did and what was already shown during Ben's presentation is we create a new logical boundary, this box around our architecture, and we are simply duplicating it multiple times. Can be 2 times, can be 3 times, can be hundreds or thousands of times that we or copy our application. And so we have a cell, what we call a cell. And cell is a sort of isolation and a logical isolation unit. So we have full stacks always. And we keep the definition for now simple. So there's always a gray line where it's not yes or no, or left or right, or A or B. There's always needs for being not that strict to the definition. But the simple definition is we have a complete stack per cell. So the architecture is duplicated every time. And a cell means this is our blast radius. Failures can't or should not cascade between cells. So if we have one malicious cell because somebody injected bad code or bad content, the other cells are not affected. And the initial approach is just simple cloning. But this creates a couple of new challenges we need to talk, because in the thought process, migrating to cell-based architectures, you get a lot of benefits, but you have to tackle a couple of trade-offs and you will get new challenges when introducing this architecture pattern. Yes.
Marco, just something I'm also thinking of. You're talking about, a code change or something that's active on you as a provider that can break things. So, I mean, that's why we have CI/CD pipelines and deploying things, in these kind of waves. But I suppose it's also a logical bucket for noisy neighbor or things like that, where you have a single tenant maybe, or a single customer, or something has a huge amount of traffic, and you don't want it to impact other kind of people. So it may not just be stuff that you're doing when you're evolving this architecture with broken code, but also something beyond your control, or even a DDoS attack, or I don't know, you've gone viral or something, and one of your customers does something crazy, which is awesome for your business, but you don't want to break the rest of your business.
Yeah. I think that there's just to interrupt you a second. These kind of different dimensions on what could happen, and certain aspects of that are covered by cell-based architectures, and certain aspects are potentially not, which you need other mitigations or just accepting the risk, right? Because and it's an interesting topic about the noisy neighbor, because at some point we're going to talk about, okay, are you alone in your cell? Like, is there one customer, one client, one tenant per cell? And if not, there's still the potential for having a noisy neighbor. But this will become more interesting just a second.
Yeah. So the challenge is there are so many topics you can discuss and have to discuss when you try to evolve this kind of architecture. And this might be a good thing to make some small advertisement. The last year's talk was on serverless resilience as well, where we talked the full time on one workload and what you can do within one workload, right? And as Ben said, you can use, for example, fair queues to handle noisy neighbors within your architecture. And when we just zoom out, we are not talking about our workload as one workload. We are talking on this cell-based architecture, which can help and will help with some sorts of challenges like noisy neighbors as well on a different level, right? So you typically talk about the same architecture challenges on all levels. You have the same questions for your workload that you can apply to your cell-based architecture. Some will be then obsolete probably for your workload and can be solved on the cell-based architecture level. Some have to be solved on every level, and some will just move to a different part, like adding a firewall to the as an inbound controller for just filtering traffic out, which is malicious or as an attack, for example. But
yeah, so lots of options and different kind of things.
Yeah.
Reginaldo 8597, who said earlier he's from Brazil, he or she, I don't know if the O specifies whichever, but is this correct? Each cell is a group of the simple architecture components deployed separately in other VPCs or maybe another zone or region.
Yeah, this is something we will cover a little bit later. So for now, see a cell as a logical group without a definition if it's running in one account and within one VPC, or if it's run in one region and multiple regions. It can run in multiple regions, it can be deployed in multiple VPCs, and it can be deployed over multiple accounts, and it can be deployed using all of the three attempts at once. And all this brings new capabilities and introduces new challenges. And the interesting part
the concept is you've got multiple copies of your application running in other places.
Yeah, and from the simple definition as a cell is a logical isolated unit, you have no cross-cell dependencies. There will be requirements where you will have to introduce this, but this is a more advanced topic. But for now, cell is an isolated unit, no cross dependencies between cells. You're sharing nothing between cells. And we need to introduce two different new terms. We now have an application plane and a control plane, and we will talk about what this really means, because this is something you usually hear when you're working with AWS services, that we talk about a control plane and you have an application plane. And to just quickly define this both terminologies is your application plane is your application. Your control plane is something we haven't discussed yet, which sits outside of your application. And the combination of both is your cell-based architecture. And when we talk about this control plane, there are a couple of boxes we already added, but we need to talk about because these are important concepts. And with the first one, we need to talk about this router. So the question is, or the challenge is, when we have multiple cells, the question is, how do we know which user or which tenant or which customer is in which cell? And even if we know what happens, how do users from the outside know which user is in which cell? So probably it's not a good idea to give them a full phone book and say, let's try to find the one you're talking or want to talk to. So we need a first set of component for our control plane, which is basically called router. And to cheat here a little bit, for a router, there are a couple of different ways how a router can work, or what could be the mechanism of what a router can do. The basic approach is the top one here, where it simply acts like an application or a load balancer. You use an outbound service you can connect to, and every request is directly routed every time through the router because the router is knowing magically which account, which customer, which tenant is in which cell.
The one thing I think that's important here, because the question would naturally be like, we talk about the cell-based architecture in terms of reducing impact, inducing the scope of issues, and now we suddenly add like a single point of failure just in front of it, right? So what's even the point? Like if this router fails, everything fails as well. Like your application is not working. So what are we trying? How is this helping actually is, I think, the question.
Yeah, so it's helping because we need some sort of instance which helps us to know which user is or tenant is in which cell. And yes, it adds a new critical component to our application. And this is a component where we just need to ensure it's, I would say, up to nearly 100% of the time. And because this is now the critical component. With the first approach, the benefit is simply, it's a simple mechanism, right? You have one component, every request is routed through and is routed to the dedicated cell. The downside is this is an instance or a component of our architecture which will see a lot of traffic because every request needs to be put through this single component. So there are different approaches now. We have here in the examples, we have three. The second one is we still have a router, but it's now acting as an as a redirecting mechanism. So it could be a Lambda at edge or a CloudFront for routing decisions, for example. So we are reaching our router, asking, I would like to talk to tenant 2, for example, and we get an information piece which will be used for redirect. So the router is still the important component because it's like the index to our applications and our tenants, but only in a subset of our requests, because with the first request, I get the information your tenant 2 is routable or reachable using the following, I don't know, URL or routing mechanism. And from that point on, we are not talking to the router for the further communications. We can talk directly to the cells, for example, where the tenant is sitting. So we add some sort of more complexity with the redirect mechanism, but we get a benefit. We have still a critical component because without a router, even at least the initial requests won't work anymore. But all continuing requests besides or after the first one will still work because our client or our browser or our cache still has the information how to reach a certain tenant.
I think the term that we use at AWS also quite often is static stability, meaning that even if there is an issue, like the existing workloads are kind of not impacted. And that's the case here, where if you make a new connection and you want to get the redirect, you want to understand like which cell do I need to go to, that component or that request wouldn't work. But all the customers, all the clients or tenants that had received their redirect, their endpoint basically before, they would still be able to continue working. So that's kind of this reducing the impact and leaving the existing application or the existing workload intact, basically.
Yeah, exactly. And the last option we have is a DNS-based routing. It is from a stability point or resilience point, the most stable one, I would say, because we rely on DNS for routing. But it comes with a couple of downsides. You have to handle DNS records all the time when managing cell targets, for example, new tenants, for example, and you get DNS propagation delays. But from a stability point of view, you get a lot of benefits. You don't rely on this router because you can just publish all clients, for example, to the DNS records and can populate DNS records simply to customers, for example, like tenant1.api.your example workload, for example, and this can be routed automatically. But you still need this router as a critical component, as some sort of index routing phone tool mechanism to say, this is your tenant you would like to talk to. Okay.
And maybe just to add there, and to be clear, it's not like the last option is the best one. There is no best option, right? This really depends on, like, for example, the level of control. Like with DNS, you have like another component in your architecture that you might have less control over than, for example, the first one, where you kind of use it as a load balancer, which you can easily change and update. And also on the terms of complexity, like this component, while it is a critical, like every request goes through it, it's vastly simpler than having like a complex application. It's really just forwarding requests in kind of an abstracted way. So it's easier to test. It's easier. It's less complex to monitor and maintain. Giving you these kind of options on depending on how much control, how much dependencies, how much operational effort you want to have.
Yeah. Another important component of our control plane is monitoring or observability. So this is slightly different in terms of what you probably would think it will do. It is not monitoring your application. So within your cell for your application, you still have to do classic, I would say, let's phrase it like classic, typical application level monitoring. The monitoring from the control plane is a little bit different because you're monitoring your cell-based architecture, the control plane. Is it working? Do we hit quota limits in terms of, is a cell becoming full? Let's park this definition of cell getting full for a second. So the monitoring basically helps you to see how many cells do I have? Do I have any issues in any cell? Not if there has been an error while computing, but did a deployment we rolled out yesterday is updated in every cell, for example, and is every cell in the newest version? Is it running properly? Is it behaving like expected? Do I see increased latency in terms of the outside connectivity to a cell? So this monitoring is giving you observability and confidence in your control plane itself is working properly and as expected. And what I said, the monitoring itself is giving you some additional hints, because when we talk about cell-based architectures, is we need to be aware of the question is, how many cells do I need? How big is a cell? What does big really mean? Is it small? Is it big? What is big? And how do I define a cell is full, a cell is reaching capacity, for example? So, and in serverless, a lot of the obvious metrics we have or use all the time, like CPU, concurrent requests, probably memory, and so on, is not really helpful anymore. And so we get a new set, or we have to think of a new set of metrics, which defines what is full and what does cell size now really mean. And we usually go into more business-driven metrics like customers per cell, for example, right? Do I have 10 customers, 10 tenants, or do I have different tiers of tenants? You probably, if you know, for example, SaaS services, you always see this kind of tiered subscriptions, like a free user, freemium user, a basic user, enterprise customer, right? And this is a definition of, this is a definition which is driven by your business model. Or how do you business or your product definition? What is a customer? Is it a small one? Is it a bigger one? And this is shaping how big, small, and how many cells we need to provision, or just some other things. How many revenue do we want to achieve within a cell? Or do we have geographic boundaries? This is one of the questions we had earlier. Does a cell typically is within one region, and but cells within your application and the control plane can be spread over multiple regions. So you can have customers in the US, you can have customers in the EU, and you can have customers in Asia Pacific, for example. And all of these customers running in a cell, which is located in a specific region. Yeah. Another not so common criteria is, do I have certain requirements in terms of latency or workload patterns, that I split my applications into real-time like applications or batch processing applications. This is something we see rarely, not so often. The common ones are customers per cell, sizing of customers, and so on. So
I think,
question, yeah,
go ahead. So I just wanted to add like some kind of these anti-patterns that we do see, right? Which is you kind of define like a customer per cell, right? That is great from an isolation perspective, but it's less an operational nightmare, right? You're managing then potentially thousands or more of cells, and the overhead is just enormous at that point. And but on the other end of the spectrum, like if you define two like cells to contain a lot of customers, tenants, clients, whatsoever, it kind of defeats the isolation purpose, right? At that point, you basically have 50% or even more of your customers in one cell, and if there is an issue with that cell, you really haven't achieved the goal of limiting the impact here. And I think and the answer that we'll always give as a solution architect is kind of, it depends, right? But I think we can recommend, or like one recommendation is to start small, right? So obviously start with like a very limited number of cells and watch them grow. Because as I think we also experienced is that your customers, your clients, they don't grow all at the same rate at the same time, and some might even stop using your service or your application at all.
And I suppose there's also differences with, especially with stateful workloads. Like you've got DynamoDB there. If you decide that you want to move a customer from one cell to another, or you need to rebalance your cells or something like that, that's going to be a tough job with stateful data. Sure, you got API Gateway, SQS, and Lambda. Sure, that's it could be pretty simple. So yeah, I think a lot of different things to think about.
Yeah. So as we said, serverless architectures might help in a lot of situations. But in the downside, it will add a lot of new challenges you have to solve, for example, right? So when we talk about this remaining two boxes, lifecycle management and rebalancing, so this is something regarding your question, Julian. So first we have a new customer, right? A new customer is now, I would say, let's have a new customer subscribing to our cell. What happens is we have a customer. This customer is a smaller one. Let's have it like this and say, okay, he's now in one cell. And what we needed first is maybe there is no cell available because all other cells are full, because they are at capacity, enough customers, or just paid customers, or we see a lot of requests coming into a cell, so that we say to have some spare room left, the cell is full. So what needs to be done is on a couple of levels is lifecycle management. Probably I need to create a new cell. This comes with a lot of tasks to do. Create a cell, provision the infrastructure, add a client or add the tenant to our master data, register the client to our routing mechanism, and all the stuff that needs to be set up. Billing and all the kind of background work or back office work you have to do, and which is hopefully automated, right? And automation is a big topic as well, but let's park it for a second. So we have probably to create a new cell, and when a customer comes, we create a cell, or we have one ready, and then the customer registers, and we need to set the customer up within the architecture, which might again be we need to create infrastructures, lambdas, other services, or we have to register and add the customer tenant data to our cell architecture, like registering the customer as an additional one within the cell and so on. And now the interesting part is rebalancing as some sort of backup and restore capability as well. So what happens when we say, say our customer is growing, and say our customer is getting too large for a certain cell. So Circle doesn't help, but probably we will get it. So the thing is, what do? I simply can't tell the customer, for example, yeah, it's okay, but don't grow anymore, or create a new customer for you and have a second one of instance of you sitting in another cell. So we probably need a mechanism, right? And we need to to have a capability to say, okay, you are outgrowing your subscription level, for example, and now you want to be an enterprise customer. And with the rebalancing mechanism, we have some sort of automation and capability we have to build later, maybe sooner, but at guaranteed later, to move data out of a cell into a different cell, because this simply means when I move this circle here, I don't just have to create a new cell, register new services, I have to migrate data. And this kind of movement is what you asked, Julian, right? We need capabilities of moving your persistent data or your stateful data sets into a different cell without breaking your business. And this is a capability you need to build sooner or later when adopting serverless architectures to enable you keeping your system at health and working, and moving customers into different cells with more capabilities, higher paid subscription models, and so on.
And I think What you just said is really important, that it's a capability that you need to build, but it's something you need to automate, sorry. But because it's if you're looking at kind of implementing a cell-based architecture, you absolutely do not want to do this manually, right? So this is like a decision to go with like higher platform complexity for the sake of getting these stronger isolation and reduced impact. But especially as you grow over time, this rebalancing, these migrations, these reshuffling even for these cells will happen just naturally over time and a lot more, right? So if you go this route, you basically need to invest in automation from the get-go. Otherwise, you will at some point not be able to keep up. So I think that's something important to call out, because otherwise you're just drowning in operational complexity.
I see we have a question in the chat. Wouldn't it be more expensive over time? What exactly? So adding more complexity?
I was definitely going to bring that up. This is all great, but who's paying? And I mean, something kind of thinking in the back of my mind is, okay, serverless, pay for use. Surely that's helpful, but I suppose there are two parts of it. One is the actual cost of running your application, and then one is an administrative cost and doing things. And even, I do a lot of stuff with Lambda. Lambda runs a cell-based architecture. You can imagine that, there are trillions of invokes happening every month, and there's no way that Lambda can, afford, just from a uptime perspective, to be able to run everything just in one cell. So, Lambda also does a cell-based architecture where they need to, partition up specifically some of the bigger regions into smaller cells to do that. And they then can roll out software updates, very cautiously and very clearly, like one cell in a region, and then the other cell much later to check if things are going on. But yeah, operationally, this comes at a cost. So how do people think about the cost question? And thanks for the question, Zora.
Yeah, I think the one dimension is also what kind of Marco alluded to. So first of all, you probably only need to do this if the impact, even if like a partial impact to you, is very costly, right? So if you operate your personal to-do app, that's probably not an issue, right? But there are kind of customers out there who have applications where any impacted customer experience leads to reputational, financial, or even potentially loss of life, right? So like these very drastic scenarios. And for them, it's really important to minimize the impact, because again, you cannot prevent it. There will always be scenarios. You want to minimize the frequency or the likelihood. And if it happens, you want to minimize the impact. And for them, this is an acceptable trade-off in terms of high operational complexity, kind of offset by a higher degree of automation, but that requires skilled engineers or like a very good AI assistant. But it requires expertise. It requires these platform operations, if you want to use that word, to be able to handle this. And that's I think the one dimension. And that's also what Marco alluded to earlier about the cells based on business dimensions. Like you grow or like create new cells when they kind of, for example, reach a certain revenue. So again, you have the margins are then probably lower because you have high operational cost. So you justify, or you look at this from, okay, at what business impact, let's say a cell is impacted, what business impact can I sustain before I need to open up a new cell, for example.
I suppose the bigger picture as well is that, although this diagram looks quite simple, and you think, oh, well, as you said before, Ben, another customer, you add another cell. I mean, we're not even talking here, every 10th customer or 100th customer. I mean, with the scalability of serverless and AWS, I mean, we're talking potentially even tens, hundreds of thousands, maybe even millions of customers within a single cell, potentially, depending on what can go wrong. So I think the big thing I keep coming back to in the back of my head is you really need to understand your business and how big things can be before things are going to break to cause that kind of issue. And then Reginaldo comes back with automation. Yeah, CDK to rule them all. This seems like a so how would you envision even doing this? Because it is, even though it's application side, this is also sort of blending into a bit of infrastructure.
I mean, the question is pretty good. You have to be aware you have two levels of automation now, right? It's not a simple CDK deploy, for example, and all is going to be set up. You have you deploy an infrastructure which has the capability of deploying new infrastructure, right? So you have a two-level kind of rollout mechanism. You first roll out your control plane, and your control plane is rolling out new infrastructure continuously. And you typically see, for example, two separate streams of automation. You have probably not much updates running your control plane pipeline, maybe a few a day, a few a week, depending on your, I would say, invention capabilities or speed. But you will have probably hundreds, thousands, or tens of thousands of rollouts on your application level. So this is the inner boundary of the rollout mechanism, because this one has to be always done by when a new customer is coming, when you need a new cell, you have to provision infrastructure. Even when you're running updates, for example, this is an important part. So automation is one of the key aspects here, because you probably can manage 2 cells, maybe 10, 20 cells with people running infrastructure management, probably not clicking in the AWS console anymore, but running CDK manually. But when you're talking about the scale of thousands or tens of thousands of cells, you'll probably simply be not able anymore to do this manually, right? And then you need that degree of automation with all this kind of control plane features. And that part of it can be CDK, it can be Terraform, can be any infrastructure as code mechanism. But the important thing to understand is that there are two different ways of two different kind of deployments you're doing: control plane updates, managing your orchestration layer, and application level updates, application plane updates, which are being rolled automatically at a much higher frequency, updating your infrastructure.
Yeah, I was just having a look because I'm sure there's a I think it's quite a few years ago. Becky Weiss, who's one of our AWS gurus, I think it's what she does. It's either a builders center library or builders. What's it called? A builders library, which is some of our senior principal engineers who also talk about how Amazon actually rolls out software at scale, and in a way, it's the sort of the building of the machine to allow the machines to work kind of thing. So yeah, I think it's a good mental model, as you said, Marco, to sort of step back and you're actually building a machine to deploy cells, which then deploy your architecture. So, I mean, these can be, CI/CD pipelines, it can be kind of things, but yeah, it's a different part to think about for your application. And and then thinking about the updating and management of it. And then even your router, you've got to have something in there that's going to remember which customer talks to what. So this is a bunch of stuff to work, but it could help you.
And what we mentioned early on, but haven't been coming back to it, when you have these cells, you can start experimenting a lot with your customers in a good way, not in a bad way, right? For example, you can just roll out a new feature to a cell and see. You would be able to run roll out new features, for example, or to only paid customers in the first run and roll it out to other customers as well, for example. So you have a lot of more features you always can leverage within the Serverless architecture, right? And you're just rolling out a new feature, not to an entire user base, but to just one cell and see what happens, whatever that means, right? You're rolling out a new feature update and within one cell and see how's it going, right? Is it working? Is it not working? Hopefully it is working. But if you see this is working, and this is automated as well. And if the first cell is updated and keeps running for a day or whatever amount of time you define, you see it's working, you start rolling out that feature to more cells, to 2 the next cell, then to 4, maybe then to 20, and then to 100. And not one by one, not sequentially, but in larger batches every time, to have all your tens of thousands of cells updated within a shorter amount of time, for example. And this is capabilities you gain as well when using Serverless architectures. Again, yet the decision needs to be done if your application is worth that effort, right? And the cost that it's, because you need automation, you need maybe you need to train your people on this new architecture patterns, on new technologies. You build this kind of new architecture, you have to build and maintain a control plane. This all comes at additional costs. But if your business case is the one defining your business, it might be worth a consideration, at least thinking if this could enhance your resiliency footprint, right?
On the terms of deployment, just one thing I want to add from like a customer is don't always start with like the same cell deploying their like changes first, because that's then always the cell that gets impacted if there's like a bug in your code. So kind of like shuffle this around a bit.
Interesting. Yeah, shuffle sharding for deployments for your cells. Oh, interesting.
Well, yeah, and also that's the question. Like when we talk about, like when we look at deployments, should I start with like a smallest cell, like the one where we say, well, then the impact isn't so bad. But some of these nasty bugs depend on like a certain scale or a certain amount of requests, or only manifest like over time. So maybe starting with like your largest cell faces the issue quicker, but it's probably also not a good experience. And with the smallest cell, you then need to have a good strategy on kind of like rolling out updates, like rolling forward, rolling backwards. How do you have concurrent updates? So that becomes then also something at least to think about when going into this.
Yeah, definitely. And I know some people have also thought of having, you know, particularly fixed size cells, so you don't have a weird memory race condition in a big cell but not a small cell. So there's a lot to think about. Reginaldo does ask, you know, what AWS components could we use as the router? Because we did cover that earlier.
Could be probably anything which you can use to front your application. Can be root, depending on your routing mechanism we discussed earlier, right? Can be basically route 53, for example, could be your API gateway, but in most scenarios, it simply can't be just a simple service, because you need additional logic as part of the control plane, because the router becomes some sort of a phone book. I'm asking for a tenant 123, and somebody has to look it up what it means, really wanting to request to this tenant 123 and giving you that phone number, that web domain, for example, back. So it's probably not a simple component. It's more some sort of logic implemented. I see there's a cell routing in the chat. Yeah, this will probably describe it better.
Yeah, definitely. So that is a blog post, not a blog post, well, a documentation page, which does talk, you know, in detail about this as well. So yeah, lots to think about it. We have a minute or two. Any sort of last thoughts or things? I mean, should people to get started with, or some you know, more brainy advice? What would you suggest?
Yeah, I think already. So if we kind of switch back to like the key takeaways, and I think you already shared, because there's much more to impact, much more to unpack, and you shared the links to like the blog series we've published on Builder Center, which goes into much more detail here. And I think the three key takeaways that I would recommend is you need to really make sure that you understand what you want to protect against, right? It's not infrastructure failures. It's really on the application level, ensuring like a good, consistent user experience for most of your users. So be clear what you want to protect against. And then also be clear that this added complexity that you're trading off requires a high degree of automation. Otherwise, you will not be able to keep up. And start simple, start small. We haven't really talked about how many accounts you use, but I would recommend start with 2 accounts, start with 2 cells, and build up from there. And then when we look at deployments, think about how you can do deployments safely. As we said again, like don't start with the same cell every time. Think about which cells to start first. Like, are you looking at something that manifests at scale, or is it fair to like roll out gradually and then roll back or roll forward? So these are kind of the dimensions you need to think about.
Cool, excellent. Well, yeah. So there are some more links even in the stream notes. If you're on YouTube, on Twitch, we've put them in the Twitch chat as well. So yeah, I think this is a fascinating topic that you could probably carry on for ages, because I think that this is probably the biggest it depends that any resilience can talk about, because there's so many different nuances. But you've certainly given us some good things to think about. Well, Ben, Marco, thanks so much for joining us here on Serverless Office Hours. An hour earlier, people on this side of the world, appreciate you joining us as well. We will be back same time, same place next week. Eric Johnson will be your host next week. I'm helping running a game day, so you'll have the awesome Eric online. Yeah, thanks, Ben. Thanks, Marco. And Reginaldo, thanks for all your questions as well. Interesting content that's not AI. We're not a bot yet. Thank you, everybody. Have a good week. Bye-bye.